Chapter 9.2 Infancy and Childhood. It is a rare privilege to watch the birth, growth, and first feeble struggles of a living human mind. Annie Sullivan in Helen Keller's The Story of My Life, 1903. During infancy, a baby grows from newborn to toddler, and during childhood, from toddler to teenager. We all travel this path, developing physically, cognitively, and socially. From infancy on, brain and mind, neural hardware and cognitive software develop together. Section 9.2.1 Physical Development. During infancy and childhood, how do the brain and motor skills develop? Brain development. In your mother's womb, your developing brain formed nerve cells at the explosive rate of nearly 1/4 million per minute. The developing brain cortex actually overproduces neurons, with the number peaking at 28 weeks and then subsiding to a stable 23 billion or so at birth. Rabinowitz et al., 1996, 1999, DeCourt and Myers, 2002. On the day you were born, you had most of the brain cells you would ever have. However, your nervous system was immature. After birth, the branching neural networks that eventually enabled you to walk, talk, and remember had a wild growth spurt, figure 9.5. From ages 3 to 6, the most rapid growth was in your frontal lobes, which enable rational planning. This helps explain why preschoolers display a rapidly developing ability to control their attention and behavior. Guerin et al., 2008. The association areas, those linked with thinking, memory, and language, are the last cortical areas to develop. As they do, mental abilities surge. Chugani and Phelps, 1986, Thatcher et al., 1987. Fiber pathways supporting language and agility proliferate into puberty, after which a pruning process shuts down excess connections and strengthens others. Paus et al., 1999, Thompson et al., 2000. As a flower unfolds in accord with its genetic instructions, so do we, in the orderly sequence of biological growth processes called maturation. Maturation decrees many of our commonalities, from standing before walking to using nouns before adjectives. Severe deprivation or abuse can retard development, and ample experiences talking and reading with parents will help sculpt neural connections. Yet the genetic growth tendencies are inborn. Maturation sets the basic course of development. Experience adjusts it. Motor development. The developing brain enables physical coordination. As an infant's muscles and nervous system mature, more complicated skills emerge. With occasional exceptions, the motor development sequence is universal. Babies roll over before they sit unsupported, and they usually creep on all fours before they walk. These behaviors reflect not imitation, but a maturing nervous system. Blind children, too, crawl before they walk. There are, however, individual differences in timing. In the United States, for example, 25% of all babies walk by age 11 months, 50% within a week after their first birthday, and 90% by age 15 months. Frankenberg et al., 1992. The recommended infant back-to-sleep position, putting babies to sleep on their backs to reduce the risk of a smothering crib death, has been associated with somewhat later crawling, but not with later walking. Davis et al., 1998, Lipset, 2003. Genes play a major role in motor development. Identical twins typically begin sitting up and walking on nearly the same day. Wilson, 1979. Maturation, including the rapid development of the cerebellum at the back of the brain, creates our readiness to learn walking at about age 1. Experience before that time has a limited effect. This is true for other physical skills, including bowel and bladder control. Before necessary muscular and neural maturation, parents shouldn't expect pleading or punishment to produce successful toilet training. Here's the sidebar. In the 8 years following the 1994 launch of a U.S. back-to-sleep educational campaign, the number of infants sleeping on their stomachs dropped from 70 to 11%, and SIDS, sudden infant death syndrome deaths, fell by half. Breaker, 2005. Maturation and infant memory. Our earliest memories seldom predate our third birthday. We see this infantile amnesia in the memories of some preschoolers who experienced an emergency fire evacuation caused by a burning popcorn maker. 7 years later, they were able to recall the alarm and what caused it, if they were 4 to 5 years old at the time. Those experiencing the event as 3-year-olds could not remember the cause and usually misrecalled being already outside when the alarm sounded. Palamer, 1995. Other studies confirm that the average age of earliest conscious memory is 3.5 years. Bauer, 2002. By 4 to 5 years, childhood amnesia is giving way to remembered experiences. Bruce et al., 2000. But even into adolescence, the brain areas underlying memory, such as the hippocampus and frontal lobes, continue to mature. Bauer, 2007. Although we consciously recall little from before age 4, our memory was processing information during those early years. In 1965, while finishing her doctoral work, Carolyn Rovey Collier observed an infant memory. She was also a new mom whose colicky 2-month-old Benjamin could be calmed by moving a crib mobile. Weary of bonking the mobile, she strung a cloth ribbon connecting the mobile to Benjamin's foot. Soon, he was kicking his foot to move the mobile. Thinking about her unintended home experiment, Rovey Collier realized that, contrary to popular opinion at that time, babies are capable of learning. To know for sure that little Benjamin wasn't just a whiz kid, Rovey Collier had to repeat the experiment with other infants. Rovey Collier, 1989, 1999. Sure enough, they too soon kicked more when linked to a mobile, both on the day of the experiment and the day after. They had learned that link between moving legs and moving mobile. If, however, she hitched them to a different mobile the next day, the infants showed no learning. Their actions indicated that they remembered the original mobile and recognized the difference. Moreover, when tethered to a familiar mobile a month later, they remembered the association and again began kicking. Figure 9.7. Evidence of early processing also appeared in a study in which 10-year-olds were shown photos of preschoolers and asked to spot their former classmates. Although they consciously recognized only 1 in 5 of their one-time compatriots, their physiological responses, measured as skin perspiration, were greater to their former classmates whether or not they consciously recognized them. Newcomb et al., 2000. What the conscious mind does not know and cannot express in words, the nervous system somehow remembers.